All right, so today we're going to cover the big ideas in chapter 2. So the first thing is functions. So, first of all, is it a function? All right, to check, you can use the vertical line test. In other words, so that means algebraically for every x, there is only one y. So for every x, there is only one y. The function will pass the vertical line test. The domain is your x values. Anywhere where the graph is defined for x, and the range is your y values. Composite functions are when you have two different functions, f of x and g of x, or however they're named, and you're going to take one of them and plug into the other. So the steps are to take whichever one. So f of g of x, we're taking g of x and plugging it into f of x. When you're doing this, make sure you use parentheses. Everywhere there's an x in f of x, you're going to replace that with the entire g of x function. So plug in, make sure you use parentheses, and then you're just going to simplify algebraically. Sign diagrams. So a sign diagram, you're going to have a line, and on the line, you're going to need to mark any critical values. So critical values will include things like x-intercepts, asymptotes, or where the function is undefined. So then you mark whatever those values are on the graph, and then you state whether the function has positive or negative y values. So if it has positive, put a plus, negative, put a minus, and so on. Rational functions. So rational functions are going to have asymptotes for their graphs. To find the vertical asymptote, set the denominator equal to 0. Then just solve for x, and that will be your vertical asymptote. It will be x equals something. For your horizontal asymptotes, though, you have a couple of options. So first option is if the degree of the numerator is less than the degree of the denominator. Your other options is if your denominator is less than the numerator, or if they're equal. So three options depending on the degree of the numerator or denominator. So degree deals with the exponent with the x. So if the degree of the numerator is less than the degree of the denominator, your horizontal asymptote is going to be a y equals 0. If the degree of the denominator is less than the degree of the numerator, there is no horizontal asymptote. There's none. And if they're equal, then it's the line y equals the top coefficient over the bottom coefficient. So that's how you find asymptotes with rational functions. Inverse functions, the notation for that, f inverse of x. The graphical relationship, they're going to be a reflection over the line y equals x. So graphically, it would be a reflection over the line y equals x. If you want to solve algebraically, you're going to replace x with y and replace y with x. So switch x and y, and then solve for y. Doing that will get you the inverse function. And then you can check by using composite functions. If you take the inverse function and plug it into the original one, it should simplify out to x. Or if you take the original function and plug it into the inverse as a composite, that will also simplify to x. So that is how to check if you did the inverse correctly. And remember, when doing inverses, the domain will become the range, and the range will become the domain. And a true inverse has to pass the vertical line test. So originally, for a function to have the inverse, it needs to pass the vertical line test to originally be a function. But if it passes the horizontal line test, so if you have a function that passes a horizontal line test, it will have an inverse.